Okay, let's look at problem 20.7. Here we have the temperature going up and down around 66 degrees. Okay, so the average temperature is 66 degrees. It goes up 23 above that. Our amplitude's 23, so it gets as high as 89. 23 plus 66 and gets as low as 66 minus 23, which is 43 degrees over a period of 24 hours. So over a daily period. They say that it starts at time 0, which is midnight, which is nice, makes sense. So period 24 hours, daily period, temperatures average 66, goes up to 89 in the daytime, and it reaches the average at 7. That's this phase shift here, where it reaches the average going up. So at 7 o'clock is 66 degrees, and it's just going up then on its way to 89. Okay, so the first thing we should do is graph this, because they want to know how long do we need to wait to get to 48 hours above 75 degrees. So we need 48 hours above 75 degrees to dry our paint. So when will the door be dry? So what time, on what days, how many days after time 0 will the paint be dry? You paint the door at the house at 5 p.m. on Monday. Okay, so when will your paint be dry? So the question is, what temperature is at 5 p.m. on Monday? And then we got to get 48 hours above 75. And the average is 66. So, every day we're not going to get a lot of time above 75. So it's going to be multiple days. Okay, so let's graph this first. Our low point will be 43. So we don't need to go below 0. So I can just go like this. And I'm going to make it at least 2 full days. We'll say 2 days. So I'm going to make 48 right here. That's 2 days, and it'll probably take longer than 2 days, but we can get the idea, I think, from graphing 2 days. So now I'm going to try to break this up into even intervals, 12, 36, and we're just going to create time, not do AM, PM, just hours after time 0, which is midnight on the day before we painted. Midnight Sunday, and we start painting at 5 p.m. Monday. Okay, so let's put some numbers in here. Let's make this 48, we go as low as 43, as high as 23, so 89. The average halfway in between is 66. So we go up and down between here. And we know we're at 66 at 7. So I wish they'd said 6 o'clock, would have made drawing a lot easier. But they didn't make these to be easy. 18, let's see, halfway between, that's 6 to be 30. Halfway between that is 42, and then so it's 7, right about here, it's at 66. That's where it's going, in the middle, going up. That's our phase, 7 o'clock. Okay, then 6 hours later, it reaches a peak. So 6 at 1 o'clock, so a little after 12 here, so at 1, it's as high as it gets, so it's at 89. And 6 hours earlier, it was at a trough, and I don't think we need to know that, but might as well put it on. So at 1 o'clock in the morning, it was as coldest it gets, is at 43. Just helps us graph it. And then, let's see, 6 hours after 1, which is 19 o'clock, it's in the middle again. And then 6 hours after that, which is 25 o'clock, it's in the bottom again. And then 6 hours of 25, which is 31, it's in the middle again. And then 37, it's in the peak again. And then 43, it's in the middle again. And then at 49, it's at the bottom. Okay, so now we draw our sine wave the best we can. So it's going to go something like this. That one I was doing pretty good up to there. Okay, that's decent. Now we want to know, when is it 75? Okay, so let's see, 75 is 9 above 66, and 75 is how far below 89? 13? So 89 minus 14, so 14 below, so it's not quite halfway in between, it's a little bit less. So 75 is about right there, closer to 66 than it is 89. Yep, that's right. And then we want to draw a horizontal line across at 75. So we get an idea for how long each day it's above 75. So only this amount of time from right here to right here is it above 75 every day. Okay, and we started at 5 o'clock on Monday. 5 o'clock is 17. So here's 17. So that's right there. So we started there. So it looks like in my picture, we're going to have a little tiny bit of time after 5 and before it gets down to here on Monday. And then, of course, we have all day Tuesday and all day Wednesday and until finally we get to 48 hours. Okay, so now I might be wrong. My picture might be bad. But I think no, I know it's right because at 19 o'clock it was in the middle. So probably we're going to get a little bit of time here. Yeah, I think we're going to get a little bit of time on Monday after 5 o'clock. So we need to figure out what time of every day it hits 75 degrees, what time in the morning and what time in the afternoon. That's the goal. And then we got to figure out how many days and when it's going to stop. It probably won't stop exactly. Okay, so what we got to do is set this equal to 75 and figure out those 2 points. One of them is the regular solution and then the symmetry solution. Okay, so we got to use a unit circle, all that kind of stuff. Okay, so now the math part. We set our temperature equal to 75. So 75 equals 23 sine 2 pi over 24 t minus 7 plus 66. Okay, take away 66 on both sides. That would be 75 minus 66 is 9. Yep, 9 is equal to 23 sine of all that stuff. Divide both sides by 23, and I'm going to decimalize it because it's just not going to be pretty. So 9 divided by 23 is 0.3913. That's good. And then 0, so that's pretty good. So I'll keep those 4 decimal places. 0.3913 equals the sine of, now I'll write it in, 2 pi over 24 times t minus 7. Take the inverse sine of both sides to get rid of this sine. Inverse sine cancels out sine. So sine negative 1 of 0.3913 is equal to 2 pi over 24 t minus 7. Okay, and so what is the inverse sine of 0.3913? And this is where we draw a unit circle to try to wrap our heads around it because these things are tricky. So sine is the y value. The y value is 0.3913. So here is 0.5, here's 1, so that's about 0.4. So right about here, we want to know when the y value is right there. What angle is it right there? So we have this angle, but then we also have, it's also 0.3913 on the other side. So we have the small angle and the big angle. The small one is what our calculator is going to give us. Call that theta, whatever. The big one is going to be pi, because here's pi, minus theta, right? All the way here, minus theta back, because this angle is also theta. So we have 2 solutions. We have theta, and it's not just theta. We have theta plus 2 pi n, multiples of 2 pi, because we can go around and around and around and around. And we have pi minus theta plus 2 pi n. We have those two. This is the regular solution, and this is the symmetry solution. The regular ones, what our calculator gives you, you got to figure out the symmetry one, this one over here, because functions can only give you one answer, and so we got to figure out the second answer. Okay, so I'm going to go inverse sine of, make sure your calculator's in radians, inverse sine of 0.3913, and I get 0.4020. So boy, keeping 0.4 is pretty good. Let's keep 0.402, because that's really good, because the next one's a decimal. So 0.402, so this is equal to 0.402. That's how many radians this angle is, plus 2 pi n. Or this can be equal to, there's 2 solutions. It can also be equal to 2 pi over 24 t minus 7 equals pi minus 0.402, pi minus 0.402 plus 2 pi n. Those are all the times, infinitely number of times, when it reaches 75 degrees. We just need to know, the first ones here. And then we can figure out, 24 hours later it's the next one, 24 hours later it's the next one, all that kind of stuff. So, we just can use the first one here, so we can just use 0.402, and then we can use the next one after 0.402, which is probably pi minus 0.402, and figure out those two. So we don't really need the 2 pi in here, but that's showing us we're going to get all the other ones. Okay, so when is it equal to 0.402? So let's do that math. So I'm going to draw a line here. These are two solutions here. I'll put a box around those so we know what we're talking about. And then I'm going to do this first one. So 2 pi over 24, write the whole thing out correctly. 2 pi over 24 times t minus 7 equals 0.402. Multiply top and bottom by 24 over 2 pi, so times 24 over 2 pi. That cancels that out. 24, yep, that's right. So times 24 divided by 2 divided by pi. I got 1.5357, let's say 1.536. So t minus 7 equals 1.536, or t is equal to, just add 7 to that, I can do that in my head, that's 8.536. So 8.536. Okay, that is, looks like this point right here, right after 7. So this point right here is 8.5, and again my picture is so crammed I can barely write that, but I'm going to try. So this point right here, I'll draw an arrow to it, that point right there is 8.536, so a little after 8 o'clock, well 8:30, 8.536. This is where drawing a big picture really helps, you can label it well. 8.536, that's right here. I could put it right here, that might be better. 8.536, that's the time there. Now we got to figure out this dot. That's going to be our other one. Okay, so let's do that one. So we have 2 pi over 24 t minus 7 equals pi minus 0.402. What's pi minus 0.402? Pi minus 0.402 is 2.73, and about 2.74. 2.74. Multiply that by 2 pi, by 24 over 2 pi. 24 over 2 pi to cancel out this. So times 24 divided by 2 divided by pi. I get 10.46. So t minus 7 is equal to 10.46. Or t is, add 7, 17.46. So this point right here, where it goes below 75 degrees, is at 17.46. Okay, so hit 75 at a little after 8 o'clock, 8:30 in the morning, 8.5 hours, and then goes below at about 17:30, which is 5:30. So there will be a little bit that first day. Okay, so about 0.46 of an hour, a little under half an hour. Because it goes, we started finished painting at 5, and 5.46, because 5 is 17 o'clock, yep, that's right, is when it goes below an hour. It goes below 75 degrees. Okay, so the very first day we have 0.46, that's day 1. Let's add all these up. Then every day then we have 17.46 minus 8.536. That's how many hours a day it's above 75 degrees. So that number is, let's just do that subtraction here. I'll do it over here. So 17.46 minus 8.536 is 17.46 minus 8.536. I get 8.924. 8.924. So that's how many hours every day we're going to be above 75 degrees. Okay, so how many of those fit into 48? Because we need 48 hours to dry. So if every day we get 8.92 hours, we need 48 hours. So let's do that. So 48 divided by 8.92 is 5.38 days. Let me write that down. So 48 divided by 8.924. Make sure I did that right. 48 divided by 8.924 is, yeah, 5. Actually, I think I keep hitting that wrong. Try that again. 48 divided by 8.924. 8.924 is 5.37, about 5.38. So 5.38 days it'll take. But we already got a 0.46 day from the first day. That's how many whole days. So we're probably going to be at about, that's how many hours, sorry. No, that's right. That's how many days it's going to take. So 0.38 days plus a little bit more. So we have to add 5 days. So we're going to have 0.46 plus 5 full days, and then we got to figure out what fraction we have left. So plus 5 full days, so plus 5.8924. So we have the first day, we only have 0.56. We get 5 full days. Let's figure out what that is. So 5 full days is 5 times 8.924 is 44.62. That's 0.46 plus 44.62, which is 45.08. Okay, so the first day we get 0.46. 5 more days, we're up to 45.08. So this is day one. This is 5 more days. That's day 5. So now we're in day 6. So in day 6 we've had 45.08. So somewhere on day 7 we're going to get to, we need that extra amount, that extra 3 hours or so. So let's figure that out. We need 48 hours after 6 days. First day 0.46, 5 more full days, we're up to 45.08. So we need 48 minus 45.08, which is, we need 2.92 hours on the 7th day. And then we'll be good. Then we'll get 48 hours above 75 degrees. Okay, so we go through that again. First day 0.46, we start at 5 p.m. Then we get 5 full days. Each day we figured out was 8.924 hours above 75 degrees. That gave us 45 hours, so we know we're going to need one more day, and just part of a day. Okay, so we need to figure out when it's 2.92. So what's 2.92? However, we know that every day it gets above at 8.536, right? This is where we know every day at 8 o'clock and a half, 8.536 hours, it hits 75. So on our 7th day, we know we're going to reach that at 8.536 plus 2.92 hours. So the time on the 7th day we're going to get there is the time it hits 75 degrees, which is little after 8:30, 8.536 hours, plus we're going to have 2.92, and so what's that? Plus 8.536, so that's going to be 11 points, I'll keep all decimal places, 0.536 hours on the 7th day. So at about a little after 11 o'clock on the 7th day, we'll get our extra 2.92 hours in. Okay, now we could stop there and say, okay, we figured out. But how many hours after midnight is that? So that's 6 full days plus this amount. Okay, or really that's probably good. You know, we can say 11 o'clock on the 7th day. That's when it'll be dry. I don't know. We could figure out the hours. So let's just figure out the hours. So that's 7 times 24, 7 full days. No, 6 full days because it's on the 7th day. 6 full days, 6 times 24 plus 11.456. So 6 times 24 plus, then the last day it's 11.456 when we get there. So 6 times 24 plus 11.456. So that's a time 155.456. So if we just go by linear hours, this is when it'll be dry. Or if we go by days, 11 o'clock, 11.456 time on the 7th day. I don't know how they gave the answer. Did they figure out the actual time in PM? let's see, this is 20.7, 8.926 hours of dry time each day. Oh, they cheated. They just stopped at the 8.926, but we figured out the exact time because that gives us, yeah, they figured out. I got 8.924. They said 8.926. So it depends on decimal places. So we did better than them. We figured out the exact time, which is this, 11.456 hours on the 7th day, or this much after 0. Okay, so that's how you do these. It really helps to draw a picture so you can kind of visualize what's going on. We had to figure out that first day, how much, where it started, and then how much each day, and figure out how many days, and a whole lot of calculations. These problems are long. I barely fit it on one piece of paper. Okay, good. Hope that helped. Thanks for listening.